Hello, this is Dr. Hanaa Assil, and this is paper 1C of June 2019 or May 2019. This is in the Pearson Edexcel IGCSE chemistry syllabus. So let's take a look at the questions and discuss the answers. The first question here says potassium permanganate is a purple solid that is soluble in water. A crystal of potassium permanganate is placed in a beaker containing water. After a short time, the crystal becomes smaller and the liquid at the bottom of the beaker becomes purple. Now, when we put potassium permanganate in a beaker, remember that the crystals, it's already said that the crystals are purple, and you should know that potassium permanganate is purple. Now, when I leave this crystal at the bottom, what first happens to the crystal is that the crystal starts to dissolve. And then the beaker is left until there is no further change in the appearance of the liquid. Which statement describes the final appearance of the liquid? So if we're starting with this, it will continue to dissolve and spread until all the liquid is purple. Which process causes this change in appearance? So when we put a crystal of potassium permanganate at the bottom, it spreads to all the liquid. Remember, this is a process of diffusion. Diffusion is the movement of particles from an area of high concentration, so that's at the bottom where I have a lot of the crystals, to an area of low concentration, so that was the top of the water where we started with no potassium permanganate, and this is down the concentration gradient, so it is diffusing through the gradual change in concentration from high concentration at the bottom to low concentration at the top. The formula of potassium permanganate is this. How many different elements are there in potassium permanganate? Let us take a look. If you look at the periodic table, K is potassium, Mn is manganese, and of course O is oxygen. So I have 3 different elements in this compound. Question 2 says the diagram shows parts of the periodic table with elements represented by L, M, Q, R, and T. The letters in the diagram represent elements but are not their chemical symbols. Now the question is, give the letter from the diagram that represents a noble gas. Of course, you should know that a noble gas is the one in group 0, so the one in group 0 is T. Elements L and M are in the same group. Where is L and M? They are in the same group, they are in group 1. State why they have similar chemical reactions. Remember that elements in the same group would have similar chemical reactions because they all have the same number of electrons in outer shell. So anything in group 1 has 1 electron in outermost shell. In group 2, they have 2 electrons in outer shell, and so on. An atom of element Q has 31 protons. So where is Q? That's Q. And we're told that it has 31 protons. Use this information to explain how you can determine the number of protons in an atom of R. You should realize that as we go from left to right, the elements are arranged according to what? They are arranged according to atomic number. So as we go from left to right, the atomic number is increasing. So if Q is 31 protons, then where we have in 4, the one next to it would be 32, R would be 33 because the atomic number of R is 2 more than Q. A student does these 2 tests on a solution made from a white solid. So they did a flame test and they got a red flame. Give the formula of the ion that produces the red flame. First of all, you are required to know these colors. Flame tests. So, which one gives red? You realize that the one that has lithium. And these are tests for ions, not for metal. So, when he says give the formula, it is not Li. It is the lithium ion, which is Li plus. Lithium is in group 1. It has 1 electron in the outermost shell. So, when it forms an ion, it loses that electron and becomes +1. So if I add acidified silver nitrate and I get a cream precipitate, so silver nitrate, that's the silver ions from the silver nitrate, react with the bromide ions and they form silver bromide, and that is the cream precipitate. So if the question says name the cream precipitate, it is silver bromide. If I add silver something to something that has bromide, it gives silver bromide, which is a cream precipitate. So from what we have done, identify the white solid. What did we find? We found that it has lithium from the flame test, and we found that it has bromide from the test with silver nitrate, and that means my white solid originally was lithium bromide. The student uses a clean metal wire in the flame test. State why the wire should be clean when used in the flame test. Remember, if we say, how do we perform a flame test? The first thing we should do is clean the platinum wire in concentrated hydrochloric acid, and then dip the wire in the salt, and then dip that into the hot or non-luminous flame of the Bunsen burner. So why are we cleaning the wire in the beginning? Of course, this is to remove any impurities or any traces of previous substances that would affect the color of the flame. The table lists properties of some metals. Add ticks to the table to show the 2 properties needed in a metal wire used in a flame test. Remember, which metal do we use for a flame test? We use platinum. Now, platinum is a transition metal. Why do we use platinum? Why don't we use something else? Zinc, copper, iron? This is because we need something that what? We're going to put it into the hot flame, so we need it to have a high melting point. I want it to melt when I put it into the Bunsen burner, and we need it to be unreactive so that it does not react with whatever sample I am testing. A student uses this apparatus to investigate the colors in 4 different inks, A, B, C, and D. Explain 2 mistakes the student made when setting up his experiment. What is wrong with this diagram? Can you see a mistake? Well, first of all, what does it say? It says the baseline was drawn in ink. Remember the baseline, that's the line we draw near the bottom of the chromatography paper to put the spots on it. And you should know that this baseline should not be drawn in ink. It should be drawn in pencil, because pencil or graphite does not dissolve in the solvent, while ink would dissolve and affect the results. What other problem do we have with this setup? The level of the solvent. He has water all covering the spots. That is not right. Remember, the level of the water should be below the baseline so that the spots do not dissolve in the water. So this is the 2 mistakes that the student made. Now, another student does the experiment, does not make any mistakes, and these are her results. State how many colors in ink D. Where is D? Remember, how many colors just means how many spots. As we go up the paper, the sample was divided into how many spots? It was divided into 3 spots. That means it has 3 colors or 3 dyes. State which of the inks tested could be mixed together to make ink D. Now you can see that if I have spots going up the same height, then they're the same. So if I look at D, which of the others are present in D? Well, I can see that A has a spot the same height as that in D, and B also has the two spots that are in D. So if I mix A and B, then I have the mixture which is referred to as D. Explain which of the inks tested is insoluble. How do I know if something is insoluble in the solvent? If it remains on the baseline, it did not move up the paper, that means it is insoluble in the solvent that is being used. Question 5 says, in 1937, an airship full of hydrogen gas flew from Germany to America. What's an airship? It's something like an airplane, but it's like a balloon. So, which property of hydrogen makes it a suitable gas to use in an airship? We can use hydrogen. Why? Remember that the gas we use should be what? Should be a gas that has low density so that it can go up in the air. So we can use hydrogen because it has lower density than air. But then he says, explain why helium is now used in airships instead of hydrogen. You should remember that the difference between helium and hydrogen is that helium is unreactive while hydrogen is flammable. Remember that they are both low density. And please remember that helium is actually heavier than hydrogen. So don't say we use helium because it is lighter or lower density. No, it's actually higher density. It has a higher mass than hydrogen. So it is higher density, but we prefer it because it is unreactive while hydrogen is flammable and may explode. Hydrogen is used to manufacture ammonia. Hydrogen is reacted with nitrogen using an ionic catalyst. And I'm going to remind you that this is called a Haber process. And he says, give a chemical equation. Chemical means simple and balanced. So what are we saying? Hydrogen plus nitrogen to give ammonia. Again, I'm going to remind you, hydrogen and nitrogen are diatomic. And that means if they're standing alone, I cannot just say H. The molecule is made up of two atoms. So it has to be H2, N2. And we're given already the formula of ammonia if we don't remember it. And then please remember to balance. You cannot leave an equation without balancing. We count before and after the arrow and we increase the one that is less. So, how many hydrogens do we have before the arrow? We have 2. How many hydrogens after the arrow? We have 3. We also have only 1 nitrogen after the arrow while we have 2 before the arrow. So, I should put these balancing this way. I have 6 hydrogens, 6 hydrogens, 2 times 3 and 2 times 3. And we have 2 nitrogens before the arrow and 2 nitrogens after the arrow. So now this is balanced. I'm going to remind you that this reaction is called Haber process. And we talk about this when we're talking about reversible reactions, because this is actually a reversible reaction in which we get nitrogen from the air, hydrogen from natural gas or from cracking of hydrocarbons. When we react these, and notice the conditions, you're supposed to know the conditions of this reaction. We do this at about 450 degrees Celsius, 280 m pressure, and we use iron as a catalyst. This gives ammonia that can be liquefied and separated from the mixture. So this is a Haber process. State why a catalyst is used. Why do we use a catalyst? You should remember. A catalyst is a substance that increases the rate of a reaction. And you should know why. A catalyst increases the rate of the reaction because it provides an alternative pathway for the reaction, which lowers the activation energy. So whether we're talking about an exothermic or an endothermic reaction, using a catalyst lowers the activation energy by providing an alternative pathway for the reaction. So it causes the reaction to occur in a different way that has lower activation energy. So we use catalysts to speed up any reaction or to increase the rate of the reaction. Question 6 says the reactions of metals with water and with dilute sulfuric acid can be used to determine the order of reactivity. So the table shows reactions of 4 metals with water and sulfuric acid, and we are required to show the order of reactivity of these metals. Again, remember that if this is the electrochemical series or the reactivity series, the ones at the top are the more reactive. So remember, the ones at the top would react with cold water, and when they react with cold water, they form the metal hydroxide plus hydrogen. Now, less reactive metals will react with steam to give the metal oxide plus hydrogen, and those below hydrogen in the electrochemical series would not react with water or with acid. So if we look at the metals given, W did not react with water and did not react with sulfuric acid. So if it does not react, that means it is what? That means it is lower in reactivity than hydrogen. So it's very low in reactivity. X reacted slowly with water and quickly with acid. So X would be more reactive than W. Y, no reaction with water and reacts slowly with acid. So Y is somewhere in between. And Z reacts quickly with water, violently with sulfuric acid. So Z must be the most reactive of these. So this would be the order. And please note, is he telling you to arrange it from most reactive to least or the other way around? So this is the correct order. State which metal could be copper. So this is what we did. Remember, copper is less reactive than hydrogen. It does not react with water or with acid. So W must be the one that is copper. State which metal could be magnesium. Again, we said magnesium is the one that reacts very slowly with water but reacts quickly with acid. So that must be X. A displacement reaction can also be used to decide the order of reactivity of 2 metals. State 2 observations made when excess magnesium powder is added to an aqueous solution of copper sulfate. Basically, we're adding magnesium to copper sulfate, and you should remember that copper sulfate is a blue solution. And then when magnesium reacts with copper sulfate, you should know that magnesium is more reactive than copper. So it will displace it to form the copper metal. And you should realize that the copper metal is a reddish brown solid. So first of all, when it reacts, the blue color of the copper sulfate solution disappears or becomes colorless. And the formation of copper metal at the bottom of the beaker is seen as a reddish brown solid that is formed. Diamond, graphite, and silicon dioxide all have giant covalent structures. The diagram shows the structures of these 3 substances. Explain why silicon dioxide has a high melting point. All of these would have high melting point. Why? You should realize that all of them actually have giant 3-dimensional structures with many strong covalent bonds. Don't say strong attraction forces. They're not strong attraction forces. They're actually strong covalent bonds holding the atoms together, and these need a lot of energy to be broken. So this applies to any of these: diamond, graphite, silicon dioxide. They have a high melting point because of the giant three-dimensional structure with many strong covalent bonds, and these need a lot of energy to be broken. Now explain why graphite conducts electricity. You should know that in graphite each carbon is covalently bonded to how many? Each carbon is covalently bonded to 3 other carbons, so there is an electron. Carbon has 4 electrons. It used only 3 for bonding, so there are free delocalized electrons that are free to move, and this allows graphite to conduct electricity, and that is the only non-metal that conducts electricity. Please remember to mention that it has delocalized electrons. That means electrons that are not fixed in the atom, and these are free to move, so that is why graphite conducts electricity. State why diamond is hard but graphite is soft. We said diamond is hard, and this is because it has strong covalent bonds between the carbon atoms in rigid three-dimensional tetrahedral structure. While graphite is soft, why? It's soft. Remember that there are weak attraction forces between the layers, and this causes the layers to slide over each other. Then question 8 says ethene can be converted into chloroethene in a 2-stage process. The first stage is to convert ethene into 1,2-dichloroethane. Ethene is reacted with hydrogen chloride and oxygen. Complete the equation. So basically we're required to balance. Again, how do we balance? Before the arrow, we have 2 carbons. After the arrow, 2 carbons. Before the arrow, we have 2 oxygens. After the arrow, we have only 1, so let's put 2 here. That means now after the arrow, I have how many chlorines? I have 2 chlorines after the arrow. I needed 2 here. Let's count hydrogens. Before the arrow, 4 plus 2 is 6. After the arrow, 4 plus 4 is 8. So I need to change these so that now it's balanced. Now we have 4 carbons, 4 carbons. 2 times 4, 8, plus 4, 12. After the arrow, 2 times 4, 8, plus 4, 12. 4 chlorines, 4 chlorines, 2 oxygens, 2 oxygens. It is now balanced. Please count before the arrow and after the arrow and increase the one that is less and keep going until it is balanced. And please increase one by one. Don't increase a lot unless it's obvious that it should be more than 1. Okay, in the second stage, 1,2-dichloroethane is converted into chloroethene. This is a thermal decomposition. What is meant by thermal decomposition? Remember, the reaction is thermal decomposition if we are using heat to break down the compound. So thermal decomposition means breakdown of a compound using heat. The diagram shows the displayed formula of chloroethene. State why chloroethene is described as unsaturated. What does unsaturated mean? You should realize that unsaturated means it has a C double bond C. It has a double bond between carbon atoms, not a double bond between carbon and oxygen, for example. Carbon double bond makes the compound unsaturated. Now describe a test to show that chloroethene is unsaturated. That means we need a test for Alkenes. What was the test for alkenes or for unsaturation? We add bromine water. It turns from orange to colorless, or you could say reddish brown to colorless. Name the polymer formed from chloroethene. Do you remember how to make polymers? If I'm starting with chloroethene, we said I can have many of them, an n number of them, and join them to make a long chain. And we said if we're required to draw the polymer, you remove the double bond, put a bond on the right and a bond on the left to bond it to other molecules, and then we copy exactly what was bonded to each of these two carbons that had the double bond. So that is the polymer, that's the structure of the polymer. Now how do we name it? If we're starting with chloroethene, the name is poly, exactly the same name, polychloroethene, even though it is no longer an alkene, but it is a polymer made from chloroethene, so we call it polychloroethene. Halon is a compound used in some fire extinguishers, and we're given the percentage composition of this compound. Show by calculation that the empirical formula is this. So basically we're trying to calculate empirical formula. How do we calculate empirical formula? First, divide by mass number in order to get the number of moles of each. And then we need to simplify these ratios, so we divide by the smallest. And this gives me a ratio of 1 to 1 to 3. Please do not stop here. This tells me that the empirical formula is CBrF3. The diagram shows the displayed formula of a molecule. Draw a dot and cross to show all the outer electrons in this molecule. Of course, you're going to look at the carbon. Carbon has 4 electrons in its outer shell, so it's going to use 1 to bond with each of the other elements. But each of the others have 7 electrons in their outer shell. So they're going to use only 1 of them to bond with the carbon, and we're left with the rest of the 7 surrounding each fluorine and the bromine atom. The boiling point of halon is low. Explain why it has low boiling point. If we say anything has low boiling point or low melting point, this is because it has weak attraction forces between molecules that need a small amount of energy to be broken. Remember, anything that has low melting point or boiling point would have weak attraction forces between its molecules, and this is what we're trying to break in order to separate the molecules so that it melts or it boils. And if the attraction forces are weak, then it needs a small amount of energy, so low boiling point or melting point. There are 3 isomers with molecular formula C5H12. One of these isomers is this compound that is drawn. State what is meant by isomers. What do we mean by isomers? You should know the definition. Organic compounds having the same molecular formula but different displayed formula or different structures. So if we have this is pentane C5H12. Now we're required to draw the formula of an isomer. Remember, how do we draw isomers of an alkane? Alkane means I'm going to rearrange the carbons. So the one on top has all the 5 carbons after each other. So either I put them 4 in a chain and 1 branch in the middle, not on the end. Remember, if you put that branch on the end, you're not changing the molecule. You have to put the branch somewhere in the middle, or you could have 3 in a chain and you have 2 as branches, any of these would be isomers of C5H12. Pentane reacts with bromine in presence of UV light. Complete the equation. Of course, this is an alkane with a halogen in presence of. So the conditions needed are UV light. What happens when I react an alkane with a halogen? We remove one of the hydrogens. So instead of having C5H12, I now have C5H11 and replace that with a bromine. So replace one of the hydrogens with one bromine so that my other product is the H I removed and the other bromine, so that is HBr. What is the name of this type of reactions? Remember, alkanes with halogen, they do substitution reaction. Of course, the word substitution means you're removing something and putting something instead of it. So this is a substitution reaction. The gas burned in a Bunsen burner is methane. Remember, methane is what we refer to as natural gas. So methane is the main constituent in natural gas. And we use that in our Bunsen burners and in our cookers and so on. The equation for the complete combustion of any alkane would give carbon dioxide plus water. And we're required to calculate the mass of oxygen required to react with 32 grams of methane. So I'm given mass of methane, and we said when we're given information about something, the first thing we do is we get the number of moles. How do I get the number of moles from mass? Number of moles is mass over molecular mass, which we're already given. And this means we have 2 moles of methane. Now, we are asked about what? About oxygen. I go to the equation. The equation states that if I have 1 mole of methane, it reacts with how many moles of oxygen? 1 reacts with 2, and that means that the number of moles of oxygen are actually twice that of methane. So if methane is 2, that means number of moles of oxygen is 4. And now I can get mass. We said, how do we get mass? If we want the mass, it is number of moles times mR. And remember, this is mR of O2, so this is 16 times 2. And that means it is 128 grams. Then the question says the diagram shows methane burning in air. It also shows how the 2 gases formed. Remember, we said we form what? Carbon dioxide and water vapor in this case. Explain why water collects in the U-tube. Of course, it comes out as water vapor, but then it's going into the U-tube that is inside a beaker containing ice and water. So, of course, the water vapor is cooled and condensed by the ice. Describe how anhydrous copper sulfate is used to test for water. Remember, chemical test for water is what? We put anhydrous copper sulfate. It turns from white. You should know that anhydrous means it has no water in the crystals. This is white. Now, when it is hydrated or it has water in its crystals, then it becomes blue. So remember the chemical test for water. Add anhydrous copper sulfate. It turns from white to blue. Explain the change in the appearance of the lime water. What happens to the lime water? You should remember that. We're passing carbon dioxide gas through it. The lime water becomes milky. Now, why does it become milky? You should remember that. Carbon dioxide is acidic. Lime water is actually calcium hydroxide. So if I pass, and calcium hydroxide, of course, is basic. So I'm reacting acid plus base. This gives a salt plus water. In this case, it gives calcium carbonate. Calcium carbonate is something that does not dissolve in water, and that is why it appears to make the lime water milky. A student uses this apparatus to investigate the temperature change that occurs when ammonium nitrate is dissolved in water. She uses this method. Put 100 centimeter cubed of water into the polystyrene cup, measure the initial temperature. Add 8 grams of ammonium nitrate and stir. Record the lowest temperature reached by the solution, and the table shows her results. So the initial temperature was 20 and then it went down to 14.2. Use the results of the experiment to explain what type of reaction is taking place. So if I start the reaction at 20 and then the temperature goes down, that means the reaction is endothermic. Remember, endothermic reactions takes in heat, and that means it takes heat from the surrounding solution, so the temperature of the solution decreases. So when we say the temperature went down, then the reaction is endothermic. Show that the heat energy is about 2400. How do we get heat energy? Remember, the question says I put 100 centimeter cubed of water, and we have initial temperature and final temperature. And how do we get Q? Q is mc delta T. What is M? M is the mass of the water. And I'm going to remind you that when he says mass of 1 centimeter cubed of solution is equal to 1 gram, this is just to tell you that for water or for a solution, the volume is the same as the mass because density is 1. So the 100 centimeter cubed is actually the same as 100 grams. So we're using 100 grams, not 1. The mass of the water is 100 grams. C is given as 4.18. Sometimes it's given as 4.2. Use whatever is given. Times the temperature change. Remember, we don't care about a sign here, so you don't need to put it as a minus. Q does not have a sign. So from that, Q comes out to be about 2400 joules. Use your answer to calculate delta H. You should know. How do we get delta H? It is Q over N. So we are given that we have 8 grams of ammonium nitrate. I can use that to get the number of moles. Number of moles is mass over molecular mass. We are given the molecular mass. So that means that the N is 0.1. And that means I can use the Q that we got, which was 2.42 kilojoule. Remember that Q comes out in joules. Usually we need delta H in kilojoules, so we divide by 1000 and we put that into the equation. Now you have to remember that delta H must have a sign. So is it minus 24 or plus 24? Remember that the temperature went down, and we said that means the reaction is endothermic, and that means the delta H must be a positive sign. Question 13 says, a student uses this apparatus to investigate the rate of reaction between magnesium and excess dilute hydrochloric acid. She uses this method. Use a graduated beaker to pour 50 centimeter cubed of dilute hydrochloric acid of concentration this into conical flask. Add a piece of magnesium ribbon with this mass to the acid. Then we put the bung. Can you see what's the bung? That's the one we use to close the flask at the top, into the neck of the flask. Measure the total volume of gas collected every 10 seconds until the reaction stops, and the table shows the results. So we have this, and we are required to plot the students' results. The graph is already drawn out for me, and we just need to plot the points. So we plot the points using small x's. Then we are required to draw a curve of best fit, and then the student repeats the experiment using 0.043 grams of magnesium, 50 centimeter cubed of 2 mole per decimeter cubed. Now, what did we do at the beginning? This was our original graph. And what was used at the beginning was, okay, 50 centimeter cubed of 2 mole per decimeter cubed, so we're using the same thing. But the magnesium ribbon used in that first experiment was 0.086 grams. Now I'm going to use 0.043 grams, which is about half the mass I used for the original graph. So what would my final graph be? Remember, I'm using less magnesium, so it is a slower reaction. And remember that magnesium is my limiting reagent because the HCl was excess. We were told that the HCl is excess. So it is the amount of magnesium that determines how much gas is given off. So if I'm using half the mass of magnesium, then I will end up with half the volume of gas. So instead of getting 80 something, was that 84 or something, I'm going to get 42 or something like that. About half the volume of gas is obtained because we are talking about the limiting reagent, not the excess. If we were talking about the excess, it wouldn't make a difference with the final product. But we're talking about the magnesium, which is the limiting reagent, so that would affect how much gas we get. And we want to label this curve as Y. Then the student repeats the experiment again using what? Using the same mass of magnesium, 50 centimeter cubed of 2 mole per decimeter cubed hydrochloric acid. So I'm using basically the same thing as that first blue curve that I have, but I'm doing it at a slightly higher temperature. So we're using the same amounts of acid and magnesium, but at a higher temperature. What would the graph look like? You should know. Higher temperature means faster, means steeper curve, so above my blue curve. But I'm using the same amount of reactant, so I will end up with the same final volume. Please don't go up and come down. It is the same final volume. It is faster, so it reaches that volume faster at less time, and it gives the same final volume of gas. The expected volume of gas produced in the first experiment is 86 centimeter cubed. So just why the volume that was actually collected is less than expected. So we expect to get 86 centimeter cubes of gas. Actually, the student collected less. Why do you think they collected less? Well, remember that we put the magnesium and the acid and then we closed the bunk. But by that time, the reaction had already started, so some gas would probably escape before replacing the bunk. Or I could say that the magnesium used was impure, so the actual mass of magnesium was less than what we calculated. The student uses a graduated beaker. What's a graduated beaker? Just a beaker that has some graduations on it. Usually we don't use a beaker to measure volumes because it's not really very accurate at all. We could use a measuring cylinder, which would be more accurate, or if we need something that is really accurate, then we need a pipette or a burette. But here we don't need to be accurate at all. Do you remember why? The acid is excess anyway, so if I add a little bit more, it doesn't make a difference. So the volume does not have to be accurate, so I can just estimate it using the beaker and that's it. The ionic equation for the reaction between magnesium and hydrochloric acid is this. Use the information in this equation and particle collision theory to explain why the rate decreases during the experiment. So as we do an experiment, any experiment, You should know. At the beginning, the rate is fast. And then it slows down. Why is it slowing down? Remember that as the reaction proceeds, more particles are reacting. They are being used up. So the concentration is decreasing and the less collisions per second. A salt can be made by reacting an acid with insoluble base. A student has a sample of copper 2 oxide. Pour 50 centimeter cubed of dilute sulfuric acid into a beaker. Warm the acid using a Bunsen burner. Add a small amount of copper oxide to the warm acid and stir. Add further amounts until the copper oxide is excess. Then filter the mixture and then obtain crystals from the filtrate. So this is basically how we prepare a soluble salt from starting with something that's insoluble. So this is the neutralization method. And the first question is, state why the acid is warmed. Why do we warm the acid at the beginning? To speed up the reaction or to increase the rate of the reaction, to make it faster. State how the student would know that the copper oxide is excess. So we're adding copper oxide until what? How do I know that the reaction has finished? If the excess solid remains at the bottom of the beaker. Then we stop and we filter. Now state why the mixture is filtered. What are we trying to get rid of? We're trying to get rid of the excess copper oxide that we added. So actually what we want is the filtrate, the copper sulfate solution that goes down. What would be the color of the filtrate? What are we making? We're making copper oxide with sulfuric acid. You should realize copper oxide plus sulfuric acid forms copper sulfate, and the color of copper sulfate solution is blue. Describe how the student could obtain a pure dry sample of hydrated copper sulfate crystals from the filtrate in stage 6. So we already filtered. What are we supposed to do to the filtrate? Remember, heat the filtrate to point of crystallization. Then cool to form crystals. And then we filter. Filter through filter paper funnel to obtain the crystals as residue. Wash the crystals with a few drops of distilled water. Dry between filter papers. He wants pure and dry. So pure, we wash with a few drops of distilled water. Dry, remember, we dry crystals between filter papers. The overall equation for the formation of hydrated copper sulfate crystals from copper oxide is this. In an experiment, a student completely reacts 9.54 grams of copper oxide. Show that the maximum possible mass of the crystals that can be obtained is 30 grams. So we're starting with what? 9.54 grams of copper oxide. So the first thing we do is get number of moles. Mass over molecular mass. We are given the molecular mass. So we have 0.12 mole of copper oxide. Next step, look at the equation. Relate the copper oxide to what are we looking for? We're looking for the mass of the products. So obviously from the equation, 1 mole of CuO would give 1 mole of the copper sulfate crystals. So the number of moles of the copper sulfate is the same. What are we required to calculate? The mass. Mass is number of moles times MR. We are given the MR. So from the calculation, it's 29.9 grams, which is about 30. In this experiment, the actual yield of crystals is 23.92. So remember, we were supposed to get 29.9, but actually when we do any experiment the actual mass that is obtained is usually less than what we calculate. So what is the percent yield? How do we get percent yield? The mass obtained, which is the actual yield, over what was calculated. We calculated that we should get 29.9 times 100, and that means the percent yield is 80%. Hydrated ammonium iron 3 sulfate is a violet solid that has this formula. The table shows some tests done on 3 samples of the solid. Complete the table to show the observation. So from the formula up there, obviously, what do I have? I have ammonium, I have sulfate, I have iron what? Iron 3. So, what's the first test? Dissolve the solid in water and add acidified barium chloride. So, the first thing we ask ourselves, barium chloride is test for what? You should know it is test for sulfate. Do we have sulfate? Yes, we have sulfate. What are we supposed to get when we have sulfate? White precipitate. Then dissolve the solid in water and add sodium hydroxide. We're adding sodium hydroxide to this. This is something we said that had iron 3. When I add sodium hydroxide solution to something that has iron 3, I get reddish brown precipitate. Add sodium hydroxide solution to the solid. Again, this was our solid. Warm the mixture. Test the gas given off with moist universal indicator paper. This is test for what? Add sodium hydroxide and warm gently. It gives off a gas. This is test for ammonium. So NH4, this is the test for the ammonium. And when we do this, add sodium hydroxide, warm gently, it gives off a gas. So we see bubbles of gas that do what? That turn the damp or the moist universal indicator paper to blue, or if it is red litmus to blue, but here he says he put universal indicator paper, so it will turn to blue because which gas is given off? Ammonia, which is alkali. A student needs to find the value of X. So we're trying to find how much water, X water. Remember, this is how we write the formula of a hydrated salt. A salt that has water in it would have the formula dot X water or some sort of water, and we're trying to get what is X. Now, the table shows the student's results. We have the mass of the empty test tube, the mass of the test tube with the salt and the water, and the mass of the test tube with the salt alone after we have heated to evaporate the water. So what would be the mass of the salt alone? The mass of the salt alone would be the mass of test tube and salt minus the mass of the test tube. So that means I have 6.65 grams of the salt alone. Now, calculate the mass of water. How do we get mass of water? It would be the difference between the mass of the hydrated minus the mass of the one without water. So 34.09 minus 28.69, that's 5.4 grams of water. To calculate the value of X, then we put it as if we are calculating empirical formula, divide by the MR of each of the molecules, the number of moles that come out, we divide by the smallest. This gives a ratio of 1 to 24, and that means that the X in that formula was 24. So it had dot 24 water. And that was the last question in this paper. I hope this was useful to you. Please check the paper, try and do it, and then look at the answers to make sure that you understand how to answer it. Please share with your friends, and good luck in your exams.